We live in a world of salt, but we do not recognize it.
Once it's salinized, you got a problem. One of the points that many farmers have said is that they're seeing salts in places that they've never witnessed problems before.
If I'm a producer and on my ground I got a problem with it, it's not overblown. That's my livelihood off that land.
Funding for Salt of the Earth is made possible by an EPA Section 319 grant administered by the North Dakota Department of Health, the Eastern North Dakota Resource Conservation and Development Councils, with support provided by the Natural Resources Conservation Service, helping people help the land, and by the members of Prairie Public.
It's a waste of fertilizer, seed, and your time and effort on it.
It went from, I would say 5 to 10% of the farm acres being affected by salinity to up to 40 to 50%. Salinity isn't a new problem. I mean, it's a worldwide problem.
If you've driven by farm fields in the upper Great Plains, you've no doubt noticed patches of white, chalky soil, usually near roads and ditches, that just doesn't seem to belong and doesn't seem to go away. Farmers wish it would. It's soil salinity, too much salt in the soil, and it can prove nearly impossible to grow a productive crop in those areas.
Overall, reduced soil health, so compaction issues, reduced biological activity. You don't have as good of soil tilth, it's harder to work the soil. A lot of that depends on your strategies that you're using for management. If you're using conventional tillage or no-till or strip-till. But it really depends on the producer and what they're willing to try.
In my area, I would say over 95% of my fields have salinity, and 80% of them have visible white spots that are well in excess of this.
And all of my producers are very concerned about it and are actively looking for answers and trying new things and trying to seed some cover crops, trying some crop rotations, trying some limited drainage when they can get the permission. So the producer is going to try to pick the crop that gives them the best economic return.
Excess salinity is caused generally by too wet of conditions, resulting in a high water table. Most agree the problem in the upper Great Plains got worse around 1993 when the dry cycle converted to a wet cycle and has never left. But the problem has been around for centuries.
The land in Mesopotamia is very flat, and irrigating that land created problems. In addition to the high temperature and high evaporation from the irrigated water, salts became concentrated, and the irrigation water coming from the twin rivers, the Tigris and Euphrates, enriched that salt in the Mesopotamia plain, and in less than 1,500 years, the problems started showing up to the point that most fertile parts of lower Mesopotamia turned into white crust. People went hungry, and cities and the empires themselves crumbled because of the loss of their wealth.
This is a geologic process, so it's been going on for a long period of time. We've got relatively young glacial soils. A lot of our soils were pushed in here by the glaciers, spread out on the landscape. And so as these soils weather, and if they're young materials, there's a lot of things to weather in there. They dissolve and go into the water. Then wherever the water goes, they carry these minerals, dissolved minerals.
Although it is a problem here, but it's no comparison to the salinity problem in other parts of the world. Just to give you an example of California, the Joaquin Valley and the Salton Sea, the problems there are much bigger. The world is losing approximately 1 million hectares a year to salinity. And there are 200 million hectares of saline land which is not producing up to its productive capacity. There are issues in the Nile Delta, especially after the construction of the Aswan Dam. After the construction of the dam, this kind of natural remedy, so to speak, of soil fertility and handling salinity stopped abruptly. Based on that, in fact, major health problems were created.
In our region, the topography of the land has lent itself to salinity problems, forcing many farmers to move this land to the Conservation Reserve Program.
When the glaciers came through here,
They ground up the Pierce Shale, and most of the salinity that is in our soil originated from the Pierce Shale formation in eastern North Dakota at least. We were just looking in our training yesterday at a soil survey that was completed in Stutsman County back in the 80s, before the wet cycle really started. There was only, I think, about 10 acres of a whole quarter section that was mapped saline.
I believe that there's no question but that some of the salinity that we're seeing and the degree of the nature of the salinity, it's a function of what we're doing with water. It's linked to the Red River Valley floods. It's linked to overland flow. So consequently, what that means is that there's simply more water on the landscape. More water either runs off the landscape, more water resides within the landscape, and there's less water that is moved back up through evapotranspiration.
That's roughly 10.8 decisiemens per meter. And in this type of sampling, it'll show less salts because we have a higher concentration of water with this soil. But that would easily equate to 25 decisiemens on the other methods, and that is restrictive to almost all plant growth.
Salinity can be invisible or visible. Either way, it is affecting the bottom line and livelihood of producers all over the Upper Great Plains. Jolene Hadrich with North Dakota State University has researched the economic impact of salinity.
What we know is that their yield is going to decrease, and that of course is going to relate into lower revenues and a lower profit level. Slightly saline would result in about a 15% yield loss. The moderate would be 50% yield loss. When I applied the average crop prices that we're receiving right now and those yield decreases, it resulted in a $150 million decrease in revenue.
I think it's first and foremost a crop problem, and secondly an economic problem. The loss of crop yields from salinization of the soil is a very, very major economic loss for our state.
I did a recent poll with our corn growers group, and it was fairly common to have producers from all over the state that are in the corn growers that had from 10 to 15% of their farms severely impacted by salinity.
In terms of an overall problem, we could say that the agricultural land in Canada, about 1/3 includes salt-affected soils. If I'm a producer, I will try to minimize any kind of problems that relate to salinity, primarily because my assessed lands, the assessments, will decrease if my lands are identified as salinized.
When we get to an EC about 8, which is moderately saline, we have at least 50% reduction in yields on wheat. We can have 75% yield loss on corn, and soybeans you might as well forget it because we're down to maybe 10% or not even worth harvesting.
Basically the problem, it's an osmotic problem. If you get too much salt on the outside and you have too much osmotic suction on the outside, it competes with the electrolyte in the plant, and the plant reaches the point where it can't imbibe water properly, and you start getting yield reductions.
Another fear is what has happened in other parts of the world: health issues, food supply issues, and water quality issues.
We constantly review the best available science from EPA and their contractors. They work with universities that develop the best toxicological information that's available to date, and we incorporate those. If it's something immediate, we do it right away in our water quality standards.
I don't think that on the basis of current EPA and CDC documents, we can conclude that sulfate is particularly damaging to water quality. As far as drinking water quality is concerned, people drink water that have a lot of salts in it. There are a very, very wide range of qualities in the waters that people drink and are capable of drinking.
Right here in this area of the field, this is one of the more obvious places that you'll see salt, or the obvious effects of the salt is this white crusting. I see too many guys trying to manage their salinity. They put some into CRP, but they don't go far enough, and then that salinity just continues to move out, and then they're mad because they don't have an impact, and it's just making it worse and worse.
And as you'll see next, the solutions farmers come up with can mean the difference between lost revenue and successful yields.
Good management practices for salinity would include definitely CRP, understanding that. Variable rate and site-specific technologies is the biggest one that I'm involved with.
Actually, in Grand Forks County here, the level of salinity is one of the higher levels in this Red River Valley. So we've tried a lot of different things. We have put some land into CRP, but we've done other things too to try overcome the saline conditions. Just crop choice is a big factor, picking the right crops, and picking crops that are tolerant to saline conditions is real important.
On the precision ag side of things, we've got different site-specific products and services that we can provide that will give the growers a handle on where their salinity is, what impact it has on their crop, and how far out that impact really is affecting their crop. That's all will wrap up eventually into a variable rate application for fertility and eventually the grower's bottom line.
It takes a little while to get established. It did the job for me. We have had salinity issues. This one hayfield, we got it from a fellow that got sick. He told the landlord that he wanted to rent it to my dad back in the early 70s. We took it over, the ground was white. It would grow foxtail, kochia, and not too good at that. And then the Garrison seemed to help. It took a long time to establish, but it is very thick. It got a good root structure where Dad could drive across it with the swather in the water and not get stuck.
Cover crops, especially deep-rooted cover crops, can have an effect on lowering the water table in an area. My favorite crop to lower water tables is alfalfa, which is a perennial, a permanent cover type crop. But alfalfa is very, very deep-rooted.
Out in Montana, they've really had a lot of success in addressing saline seeps and addressing how to correct those situations. One thing that's happened, there's been a shift in the western part of the state to no-till, so they've gotten a lot more efficient at water.
A couple years ago in 2008, we did a special initiative through the EQIP program, which allowed us to provide cost share to producers that were having issues with salinity, and that was specifically on saline seeps. What they want to see is which direction the groundwater is flowing when they start testing this, and then they want to see the levels of the water. And as the water goes down, that means the salts are going down. The soil on the surface is more productive as the salts go lower into the soil profile. You know, I can't honestly say what that piece of ground looked like before, but I was out on it last year on our crop tour, and like he said, you don't have the boggy areas out there. We drove across that with vehicles, with a school bus. There's good ground cover, and it's actually very productive.
We are able to seed everything. You get something growing out there, use up the water, try to push the salts down.
So this is the obvious saline area where we've got the white soil and nothing is growing except kochia. So we get back to almost the same spot every year. So we're not skewing our results by testing one spot 1 year and then 2 years later coming back and doing something that's better. We're probing the same area, and we've done that consistently now for 4 years. The reality is the water tables all over the Devil's Lake Basin are full to the point of discharging. We've had years in this area where I got stuck on the side of a hill. What we started doing was actually developing zone management for our fields. That idea intrigued me, of being able to apply the right amount of nutrient in the right parts of your field to match the crop yield potential. We actually use our experience then to tell the story as we go out and do seminars and meet with farmers. And a lot of farmers are a little surprised, just like I was, that the saline issue is much bigger than what they see. Almost every farmer says, well, I turn my fertilizer off when I go through those white areas. I don't fertilize those areas. I know not to do that. But they don't realize how far away the saline issue really is. And so when we create maps for those farmers and then delineate that out, that makes sense to them. Then we started a business of making those maps for other people, training people how to use them, doing seminars for people and pointing this out. This is a part of the management. I think the first solution is, one, recognizing the problem, and then two, keeping after it. It isn't ever going to go away. Water moves up and down in the fields.
would go that far, usually with the shovel.
We've been doing some work on this probably going into our third year now, and certainly when salinity is really high, then we get very low, almost no yield in potatoes.
Especially since 2005, we had a lot of rain in our area here, and I know just across the line they had some similar difficulties. Definitely brought more saline to the surface, and since then we've had a little bit more quality problems with our potatoes.
There's really nothing that physically, or chemically I should say, removes salts. You're not going to change the composition of that. You have to physically either drain the salts away or put in a crop that can tolerate the elevated levels of salt in the soil.
Late 90s, we chose to put a lot of our most severely saline land into CRP. That was a good option. I mean, that was an excellent option for us. So we put a lot of that land into CRP, and they used tall wheatgrass, for example. We've always tried to keep crop rotations. Winter cereals are good because they will generally grow on saline ground better than row crop like corn or soybeans. But you have to grow what makes money, and not that winter wheat isn't good, but you can't raise winter wheat every year, or you can't raise sunflowers every year. So you have to raise a rotation, and some of those rotations aren't always very salt tolerant.
Well, the best way to reduce your salinity problem is to drain the surface water. Oftentimes you can't do that. The passive ways to do it are to grow something. But you have this contradiction because nothing grows. The best thing to do is to grow your way out of it, and we've got to find crops that will grow, and then we've got to be able to practically grow them.
What we're doing on this plot is trying to show differences in management, things that we can do to help assist salt mobility and try to get crop production and growth. With this research here, we're trying to show that tillage is not an effective management tool for saline areas and salt areas, specifically when they have a lot of sodium, but also when they have a lot of calcium. In these plots, we did some tillage, we did some no-till, and we also did some no-till with straw cover to reduce evaporation. So I really have three basic treatments. I have a high evaporation, what we would call a normal evaporation here with our no-till, and then also reduced evaporation. And what the evaporation does is brings the salts to the surface. So we're actually increasing the salts and the concentration at the surface with the tillage and the no-till. The only treatments that are helping us to reduce it a little bit is with the straw.
I think the drainage is the big thing, to try to get rid of the excess water first, and that'll help probably pull away from it'll start to shrink some of these ponds, and that way the salts will start just disappearing on their own. And we've been in kind of a wet cycle, so that's probably part of the problem too.
From here to there, the salinity was twice as much on this plot as it was there. So within 10 feet, we had double the salinity. Even though there's not a lot of topography change, there's no soil type change, it's a water mobility thing.
We have downward movement of water right here.
With resource concerns that were coming into our office, we just really felt we needed to have some training for our employees on how to handle salinity and how to work with producers on salinity. You know, the work that we're doing right now in North Dakota and working with producers as NRCS, we are looking at trying to get into the rotation more salt-tolerant vegetation, or trying to get cover crops that are more salt-tolerant of salinity to try to treat the saline areas, but we're also looking at total landscape water use.
While growing salt-tolerant crops like alfalfa and barley or putting land into CRP are long-standing ways of dealing with and fighting salinity, a third solution is more expensive and potentially more controversial.
It's the installation of subsurface drainage pipes, that are perforated. So they're put at a depth to reduce the groundwater levels below a level that will allow the water to rise to the surface. And what it does is it drains excess water that is not needed for crop production. It doesn't affect the water that the crop needs, but it drains excess water, and it allows that better aeration of the soil, which is also important for crop growth. And with that, the salts move with the water. So wherever the water goes is where the salts are going to go. Other than that, there are other things with sodium levels in the soil. If you have high sodium levels, the potential to leach out the calcium salts will change the physical properties of the soils, and it can actually accentuate or make the soils less fit for crop production.
So there is some danger with understanding essence of tile drainage. Knowing your soils is very, very important before you install tile drainage, and having an understanding of the history and the potential for sodium-affected soils after you start to drain that water out. Tile drainage works. The advantage of tile drainage is that it allows the farmer to regulate when he gets in the field and when he gets out of the field. If there's a large rain, the land manager can pretty much guarantee that within 3 to 5 days he's going to be able to get into that field with tile drainage. Without tile drainage, it might be 7 to 12 days.
Roxanne Johnson with North Dakota State University Extension is in the midst of a 5-year study on salinity, including the impact of tile drainage.
Where you put that outlet is really, really important. Don't put it in upstream of someone's home, so it's running by their house, so they have, excess water sitting in front of their homes. Well, I'm a farm girl, so I'm afraid that if we don't have tile drainage, that there won't be farming as we know it in eastern North Dakota because of the high saline levels in these fields. You talk to these producers and it's the best thing since white bread, apple pie.
But other research from Jolene Hadrich looked into the economics of tiling, which can cost farmers nearly $600 per acre to install.
I did my analysis assuming $4.75 per bushel corn, and now it's trading at $7 a bushel on the futures market. Drainage tile would make a lot more sense now, but at $4 corn and a yield of 120 bushels per acre, farmer would be losing between $2 to $20 an acre if they put in drainage tile.
It is expensive, but it took land that was virtually worthless for annual crop production and made it good to excellent crop production lands.
Tile drainage, what we are doing here in the Red River Basin is installing drain tile to remove excess subsurface water. There's really one reason why farmers are installing drain tile on their fields, and it's for increasing crop production. We've tiled fields that farmers tell me are their saltiest fields, and in a few years, probably 3 to 5 years, they are yielding as good as their best fields. You look back here, and anytime you see a pump pumping water, there's the perception that you're making new water, and that is untrue. What we're doing is we're lowering the water table and we're creating a reservoir in our field.
We've done a variety of things. We are drain tiling, trying to get rid of some of the salts that naturally through the rain will percolate through the soil and go out through the drain tile. We've got an interesting project with the University of Manitoba. There's a couple of PhD students that are doing their thesis on water movement and saline soils. And we have got a replicated trial here in the back of the farm of about 15 acres. They will be trying to determine how the saline areas are mitigated through drainage and irrigation.
Once you take that water and move it somewhere, you've got to move it somewhere. You put it into a drainage ditch. There's the problem with our flat landscapes is it's hard to move it any long distance. The water that comes out of the drain contains salts. Now, my concern is with the drainage that you can have a transfer of problem from one field to another field or another area because that water is going to contain the salts. If the water cannot flow off freely and ponds up, then we've got the potential of salinizing other land.
Some of the preliminary numbers that I've reviewed suggest that the total dissolved solids in some of the tile drains are very, very high. I've seen them 10 and 15,000 milligrams per liter. Some very high sulfate numbers also. Now, 1 or 2 individually probably doesn't have a great effect. What's unknown is the cumulative effect of widespread tile drainage on the tributaries flowing into the Red River and the Red River itself. We do know that nitrate, for instance, seems to be very, very high in tile drainage waters.
Salinity is a global problem, but the solutions to that should be and must be local.
The causes of salinity are many, as are the potential solutions. The key for farmers and soil experts is to curtail the problem before it reaches levels that have caused economic collapse in other countries in other times. National, state, and local solutions will hopefully converge to win the battle.
Some of the crops is North Dakota is shifting into more of the corn belt types of production with corn and soybeans. We're going to see more problems emerge with saline soils if we aren't careful.
We have soils that are very, very productive, but you can drive any road in North Dakota and see examples of egregious erosion.
As government agencies, we need to work with it, with the growers, corn growers, soybean growers, and really try to address this resource concern in North Dakota.
The universal advice, which I would like to repeat, is instead of adapting the soil to the plant, adapt the plant to the soil as a biological long-term, less expensive and permanent solution.
Funding for Salt of the Earth is made possible by an EPA Section 319 grant administered by the North Dakota Department of Health, the Eastern North Dakota Resource Conservation and Development Councils, with support provided by the Natural Resources Conservation Service, helping people help the land, and by the members of Prairie Public.